Let's say you have PDF documents that are not OCR'd, so you can't read the text from them, and you want to use them in a custom GPT model. I'll show you how to do that. So first, I'm going to prove that this isn't OCR'd. So I search for the word said. I see it here and here, but it didn't return that. Then here, I'm going to ask a question of my custom GPT that was fed this document in its knowledge base. And you can see in the highlighted sections here that it is answering properly. So that's because I took all the PDF documents that were related to this project and ran them through an OCR process, which I'm going to show you how to do. So why do we care about this? Well, imagine that you have, so basically these documents are related to a real estate purchase for a condominium, which is like an association of units that all kind of work together. And there tends to be tons of documents with real estate units like that that spell out all the rules and regulations related to like the common interest of the overall community. So when you're going to buy a property like that, you usually want to understand what those rules are, but you don't want to read through 300 plus pages of documents to figure that out. None of which, by the way, are OCR'd because they're usually done, some years ago, so 1970s, 1990s, and then they were scanned into a system. So it's just like an image of the documents, not the actual PDFs. So like in this case, I wanted to know what the pet policy was, what the parking policy was, and what the rental unit terms were, because those were my three main concerns. So, for example, I have a 50-pound poodle and a cat, so I wanted to know if I would be allowed to have those pets in this unit. So I'm going to ask, please provide all the rules and regulations related to pets. And so instead of reading through 300 pages of documents to figure out if my pets would be allowed, I could just chat it here. So I see here that my dog would not be allowed because it weighs more than 30 pounds. So that's going to be a problem. So another concern I have is parking. So I have 3 cars and I want to know, can I park all 3 cars here? Please provide all the rules related to parking. All right, so each unit has 1 reserved spot. So I have a max number of cars I can park there. 2 per unit, which would be a problem. So anyways, that's the benefit that you could get out of a tool like that. And now I guess I'm going to show you how you would configure the actual custom GPT. Now how to make a custom GPT like this. So if I go, I think you do have to be a premium subscriber. But if I go here, which was just to my GPTs, and then click create, you basically name it, give it a description. And then the instructions are the prompt, essentially. So the prompt is important. I have one, don't worry about it too much, because we can just download the file from the link at the bottom of the video. So this is the example prompt that we would use. Then you add a conversation starter. So what will you start off saying? Like, how can I help you regarding condos? And then this important part here. So this is the knowledge base. So I'm just going to pick a text file here that I had configured for this. We don't care about Dolly, but we want the web search. I'm going to click create. I'm going to leave it with anyone with a link. It's useful to my realtor and my family. And that's it. So then the key part here really is the OCR part and being able to get all of the text data out of the documents, which I'm about to show you here in the next step. Okay, so we just built the custom GPT, and I'm going to show you how to do the optical character recognition, the OCR, which is the main, I guess, event. But I think the easiest way to, and again, don't worry, the files will be available for download, so you don't have to pay too close attention to all this, except where I pointed out. But I'm basically going to run the program real quick to show you how it works. So you see here, it basically, actually, I'll run it again so that you can see it. So in the console, it shows you what document it's currently reading, when it finishes reading that document, and then it tells you when it's gone through everything in that particular folder, tells you how many documents it read. And then the naming convention I did is this PDF OCR output, but then I added the date down to the second. So that way there'd be kind of a minimal chance of creating the same file with the same name. It lets you keep track of versions and whatnot a little easier too. So basically, all of the information, all the text information that was in these two documents has now been put into this text file. And it's this text file that I then upload to the custom GPT. So the way the program works is basically put all the PDFs that you want to read in this input files folder, and then the text file that it creates will then be placed in this output files folder. So the first thing that you'll notice are the imports up here of various libraries. And by the way, the reason there's a ton of comments here is just because I took the code and I dropped it into ChatGPT and asked it to comment all the functionality of the program in such a way that it would be very easy for a beginner to use it. And to be honest, ChatGPT wrote 98% of this anyways, and it was really just debugging and troubleshooting to get it to work properly. Most of the troubleshooting ended up being with some of these dependent libraries here and getting them to work. So I was working on a Windows computer and updating like the global paths to point to the like source files for these libraries was a problem. So the way that I ended up doing it is using a .env file instead, where you could explicitly state where the folders are, or the program files are located. That way you don't have to worry about like updating Windows global paths or anything like that. So I would recommend doing it the same way. So yeah, basically we need the OS in order to access different file directories and create files and save files to new directories, that sort of stuff. We need the date time because the we take the system time and we use that as part of the file name. Then PDF to image basically takes a PDF and converts it to an image per page. And then this tesseract library is what can then read the text from an image and convert it to text. So we talked about the .env. Well, maybe not, but like you need this library in order to use the environmental variables. So as mentioned, input folder is where we put the PDFs that we want to read through. Output is where the text file is going to be generated. So Poplar and in PyTesseract, these paths are just to wherever you installed or wherever you placed the like executable files from. That was an overview of the libraries, and now we're gonna dig into more of the program. So I'm gonna skip past this function initially, and we're gonna go back to it. And we're gonna go to this process PDFs and folder function first. So it takes these parameters. It gets a timestamp because it's gonna need it for the file name, the output file name. It is here making the output file name. Then here, it's searching the directory, the input file directory, to see if it can find any files that end with .pdf. If it doesn't find any files that end in PDF, it tells you that. If it does, then it's going to open the new output file, and for every file that is in the directory that was added to this list of PDF files, it's going to iterate through those. And here it's printing to console to say starting document, and then this is the PDF document name. So we would see that there's progress. And then for every time, whenever it writes the text data into that one output text file, it does a document start and a document end tag. So basically it says document start, and then it provides the PDF file name, and then it tells you which document number, 1, 2, 3, 4, 5, etc. Right? And then a little further down, it's going to also show when the document ends, so that the GPT can kind of know the beginning and end of every document that's loaded. So here, this is where the actual OCR is happening, and that's a call to the function above. But it's basically saying, with the PDF open, get the text, and then it's calling this custom function that we wrote above, which I'll get back to. So when it returns the text, it's going to write it to the output file. If there's an error, it's going to say so. And then when it's done with that, it's going to write that it's the document end, and then it's going to restart the process for the next file in the PDF file list, and just continue writing over and over and over into the document. So then we flip back up here, the get text from any PDF function. This is the one that was called here. And this is where the actual OCR happens. So it takes the PDF file and it converts that PDF file to an image, because that PyTesseract library can only work with an image. It initializes a text variable that's going to hold the red text. And then here, when it converted each page of the PDF into an image, it's like a list of images. So here we have to iterate through those images, and then it takes the text variable and it just appends whatever text it's able to read from each page that was in the list of images that was sent. This images or image to string function is actually, that's not one that we wrote, that is from the PyTesseract library. And this is the one that actually does the OCR. So this is the one that's actually reading the document. So when it's done, it's going to return this variable final text. And that's basically how the text is read out of each of the PDFs. I'll note though that like with super old files, so this particular file is from 1992 and it's actually in pretty good condition, but I also had to work with some files that were from 1975 and they were in much worse condition. The speed that the OCR will happen and the accuracy is related to the quality and cleanness of the document. So this 1992 document processed in like a few seconds, and the 1975 document literally took hours. Now to deal with that, it's beyond the scope of this video, but that explains like some pre-processing steps that you could do to speed up the OCR on old low quality documents. Basically it's like using filters and tricks to eliminate a lot of the noise. So like turn up the brightness, and they have custom functions with OpenCV and the pill library that let you just optimize old documents for OCR. So anyways, that's beyond the scope of the video. So back to the program here. Here we basically just call the function, and that's what really kind of kicks things off. And then you just tell it where the input folder is, output, and the poplar path, and it pretty much does the rest. And it kind of tells you what it's doing down here. So that's generally how the overall program works. Let the program run. I wanted to kind of show you an example of the output file. So here you've got the PDF OCR output. That's like the base name that we always name our output files. And then here's that timestamp that's appended to the end of it so that you're always creating more or less unique file names. So in the program, we covered how at the beginning, as it reads each document, it says document start and then the file name, and then like which number document is it in the overall list. So I'm going to try and scroll to where the next document starts. So document end, brochure, and document start deed. And this is the second document. So this was like the second PDF in that directory. So I see Middlesex North Registry of Deeds electronically recorded. So you see it picked all that up. When it reads tables, it gets funky. This one's okay because there's, kind of side-by-side information here, but it does tend to get a little funky eventually. So it did a pretty good job. I'm going to scroll down a little bit more to show you where I might have messed up a little bit, but not too bad. So I did delete out a little bit of information here so that it wouldn't show anybody's private info. But yeah, here you could see 240 for 100, blah, blah, blah. That's accurate. And it says grant to, I redacted that. With quit claim covenants, yep, that's all accurate. So yeah, it did a pretty good job in reading this information. See, we get to the bottom and it has some struggles, but nothing too significant that would interfere much with the use case that we have. So I think it did a pretty good job overall. Comes together. So don't worry too much about understanding too many details here. I would recommend just downloading the files, see if you could reconstruct it just like I did. And then once you get it kind of like working, then start making changes directly to it to see if you could tweak it for whatever your specific use case is. But yeah, all the resources should be linked down at the bottom, and hopefully this helps someone out. Thank you.